Welcome to lesson 2.1.3's review and preview. And we are going to just jump right into the problems. And again, if you have questions about any of the math, please leave your questions in the comments and I'll get back to you. Thanks. And here we go. So in this problem, it gives us two equations and it's a system of equations and it wants us to solve. So it says on part A to graph the system on graph paper and then write its solution, the points of intersection in XY form. So what we're going to do is we're going to start with a Desmos video to help you with that. Then we'll come back and we will solve it algebraically. Here we go. It's asking us to graph this system of equations, these two graphs, and it gives us an E tool to work with. And you see the two lines there, the blue and the orange, but by all means, they are not graphed correctly. So what we're going to do first is we're going to take care of A and we're going to graph the system on paper, which is actually in Desmos. And then we're going to figure out where they intersect, and that's going to be our system's solution. Then we're going to go back to the slide and solve it algebraically. So let's just start with y equals negative x plus 1, which is our orange equation. I'm just going to go ahead and shift this point up to 1 because I know that's my y-intercept. And that's where I'm going to put it. And then I'm going to take this point and drag it over to where it would be down 1 over 1. Okay, so down 1 over 1. That gives you that negative 1 slope that they've given us. Now I'm going to take, I have y equals 2x plus 7. So I'm going to go ahead and take this particular point and slide it up to the y-intercept of 0, 7. And then I'm going to move this point so that it shows the slope of a positive 2. So up 2 over 1, up 2 over 1. So now they're graphed correctly. So I'm going to come over here. This is our point of intersection. So that means this is our solution. So I'm going to go ahead and plot that point. Good. It's negative 2, 3. And I'm actually going to go ahead and do it like this so you can see how you can also label these yourself. All right. And I'm going to go ahead and leave the point red because it shows a difference between the two. And then I'm going to label it as solution for system. Oops, give it an extra space. Okay, and that is also negative 2, 3. Okay, so we now know that that is our answer. Let's go back and prove it algebraically on the slide. Okay, so according to our graphing process, we came up with a solution that was negative 2, 3. So I'm just going to go ahead and write that point here. Negative 2, 3. Okay. So let's see if we come up with that algebraically. Now, this is a system. And what we have is that both equations right now equal y. So the easiest way to do is to use substitution. Since they both equal y, they equal each other. So I'm going to go negative x plus 1 equals 2x plus 7. I'm going to add x to each side, and that gives me 1 equals 3x plus 7. Then I'm going to subtract 7, and that gives me 3x equals negative 6. Divide by 3, and my x equals negative 2. Well, we're right on the right track so far. So then I can pick either equation to substitute it back in. And we'll just show you both just so you believe me. So I'm going to start with the first one, and I'm going to say y equals a negative 2 plus 1. So that's going to be y equals a 2 plus 1, y equals 3. So that proves the point, okay, of our intersection. Then I'm going to say y equals 2 times negative 2 plus 7. Well, y equals negative 4 plus 7, so y is going to equal 3. So that proves algebraically that our point of intersection is negative 2, 3. Again, if you've got questions, go ahead and drop them in the comments and I can help you, all right? And that ends 2-31. Let's move on. Okay, so this particular one, it says first, what is the area of this rectangle? So what I did on Desmos is I used their E tool and I drew this shape here, okay? And so I'm going to look at this. So each side, this side is 4 units. This side is also 4 units. And each of the lengths, if you choose to make that the length, is 5 units and 5, okay? It's asking us, what is the area of this rectangle? Well, let's put part A here. It is just 5 times 4. So 5 times 4 equals the area. So area equals 20 units squared. Okay, that's pretty simple. Now, the problem with part B, and I totally agree with this, it's difficult unless you set your scale perfectly to get all of these points into a nice, neat rectangle that you can see and count. But there is an easy way to do it. So I'm going to go ahead and just sketch a triangle right now. Let's do that. Okay. All right. Let's do that. Okay. And I'm going to put at each corner one of the points. So I'm going to say that this is, let me get my pen back. This is 352, 150. This is, whoops, not going to be working that way. Got to do at least in an order that makes sense to you. Let me rewrite it. So this will be 352, 175. That's our y value. This will be 352, 150. And just looking at that, because all you're doing is looking at the y values here, okay, is that means this side is 25, okay? And we'll line up the other points and see if we're on the right track. So we will say 456, 150, okay? And 456, 175. Well, we do have the same y values on these, and the difference again is 25, okay? Now we need to look and see, we have the same x values. Let me get a different color here. We have the same x values of 456 and 352. So all we have to do is subtract 352 from 456. And that would be, if I'm doing it, I should use a calculator. But you know what? It's actually good for me to model. It's 104. Okay. So the length of each side of the opposite sides is 104. So now it wants us to calculate the area of that. So the area of this one, and let me get back to a black so you can see it easier. Area of this would equal 104 times 25, which would equal 2,600. And of course I did that in my head. No, I didn't. 2,600 units squared. So here's the answer to part A, and here's your answer to part B. Again, if you have questions, leave them in the comments, and I will get back to you. All right, moving on. So this is 2-33, and it says, looking at the diagram below, John says that the measure of angle BCF, and I'll go ahead and mark it, is equal to the measure of angle EFH. Do you agree with John? Why or why not? I do not agree. We don't know if those lines are parallel or not. So I do not agree. Nope. And then Jim says, you can't be sure those angles are equal. An important piece of information is missing from the diagram. What is Jim talking about? In order for us to assume that these two angles are equal, we would need to know that BD is parallel to EG. And we don't know that. There's no the markings are missing. Okay, so we would need to know that. So in this case, we do not know if this statement is true. You cannot make assumptions in math and specifically geometry when it comes to diagrams. Okay, hope that helps. And I'm just going to, so it doesn't present confusion later, I'm just going to go ahead and erase because we don't know if those are parallel. All right, moving on. Okay, so this is 2-34, and it says use your knowledge of angle relationships to solve for x in the diagrams below. And one thing that was key thing that was missing from 2-33 was the knowledge of whether the segments were parallel or the lines were parallel. Well, the lines are parallel on both of these problems, so we have relationships we can work with. These two are considered corresponding. So since they're corresponding, they are equal. So I'm going to go ahead and solve by setting them equal to each other. I'm going to subtract 5x. Okay, I'm going to add 63. So 4x is going to equal 70 degrees. When I divide by 4, x is going to equal 17.5 degrees. And I can say that because these are corresponding angles. So that is part A. Part B, we have a couple things we could do here. If I wanted to, I could solve, because of the parallel, I could say these two are same side interior. So I could add both of those equations together and have it set equal to 180. I'm not going to do that on this one. And then these two, because of the line, form a linear pair. So I could do the same thing by adding up 5x plus 21 plus 20x plus 34, setting it equal to 180 and solving. But I'm not going to do that either. I have chosen to use this relationship and this relationship. They are alternate interior angles, so they are congruent. Okay, so I'm just going to set them equal to each other to solve for x. 5x plus 21 equals 12x minus 14. I'm going to subtract 5x. And so I'm going to have 21 equals 7x minus 14. Then I'm going to add 14. And that will give me 7x equals 35. And when I divide by 7, x is going to equal 5. Okay? And that ends 2-34. So in part A of this problem, first of all, on this problem, 2-35, we're talking about probabilities. So when Ms. Shreve randomly selects a student in her class, she has a probability of 1/3 of selecting a boy. Okay, so if her class has 36 students, the probability of choosing a boy is 12 out of 36, because that does equal 1/3. So she has a 1/3 probability, 12 out of 36, of selecting a boy in her class. In part B, if there are 11 boys in her class, how many girls are in her class? Well, if 11 boys, if it's 1/3, then that would mean 2/3 would have to be girls. Well, 2 times 11 is 22, so it would be 22 girls in her class. And then we'll just finish up. The probability of her choosing a girl, if choosing a boy is 1/3, probability of choosing a girl is 2/3. Okay, on part D, we have two different situations here. So, well, it's the same situation, just two different outcomes. So it says the probability, she selected one student who was a boy. So the probability of the first one being a boy is, out of 24, 8 out of 24. Okay, that's the probability. Then they want to know, what is the probability that the second randomly selected student will also be a boy? So the probability that the second will also be a boy Well, we have one less possible. So 23, there's only 23 students left, and we only have 7 boys left. So that is the probability that the second will also be a boy. Okay, that ends 2-35. Let's move on. Okay, so this is 2-36, and it also gives you an E tool in the homework, which I think is really helpful because you could work it out graphically on the e-tool, and then you could duplicate that graph for your homework to turn it in. So if I'm looking at this right now, I've got on graph paper, it says draw the line segment AB, and it gives you the point for A and B. So all I have to do first is to drag these points to their spot where they're supposed to be. So we're at 6, 2. Very good. Then we're going to take B and we're going to go to 3, 5, and then it gives us our segment. Now it's asking us reflect AB across the line x equals 3 and then connect points A and A prime. What shape is created by this reflection to be as specific as possible? Well, it also gives you this little hint here. I would just typically draw a line of x equals 3, but it actually already has it drawn here. And you see that it's now something you could reflect over and it's visible, so it's easier to see what's going on. 3, 5 is not going to go anywhere, but this A, 6, 2 will reflect across x equals 3, and this is 3 points away from the line of symmetry or reflection, and then this is 3 points the other direction. So we're just going to drag this down to 0, 2. And if you look at that, it gives you an isosceles triangle. It's not equilateral because then all of these sides would have to equal 6, and that's not going to happen, but it is an isosceles triangle. You have two sides that are the same length by the definition just of the reflection. And because they're the same length, that means these angles that are formed are also equal. And so you have an isosceles triangle. Now let's work on part B. Okay, so then it says on part B, what polygon is created when segment AB is reflected across the line y equals negative x plus 6, and all endpoints are connected to form a polygon? All right. They also give you a hint here, so you can draw your line, y equals negative 6 plus, or negative x plus 6. You can do that also, but we're going to go ahead and use that. All right. Now it wants us to reflect this across, and we have our 2 points here, our A double prime and B double prime, because this is our second translation with that original segment. So I want to go across this line and reflect across. So I am one diagonal spot away from this line of reflection, okay? And so that means I'm going to take A double prime and go 1 the other direction. So I'm just going to come over here and plot that, okay? The fact that it's showing up means I'm doing it right too. That's actually helpful. Then I'm also 1 away from the line of reflection here. So I'm going to go and bring my other point to 1, 3. There you go. And what that gives us, if you're looking at that, is a rectangle. These have reflected over, so these two sides and this side and this side are equal, and this side and this side are equal, and they are perpendicular, which also forms 90-degree angles. So you have yourself a rectangle. This also ends the review and preview for lesson 2.1.3. And as I've said on other videos, if you have any questions, please leave those questions in the comments and I will get back to you. In addition, if you liked this video and it helped you out with your homework, please consider subscribing and giving us a positive thumbs up. That would be helpful, and we'll see you on the next video. Thanks so much. Bye.